im se svima, i malima i velikima, i bogatima i siromašnima, i slobodnjacima i robovima, dade žig na njihovu desnu ruku ili na čela njihova, te da nitko ne može ništa kupiti ili prodati, osim onoga ko ima žig ili ime zvijeri ili broj imena njezina.
Pozdrav, dragi narode, dobrodošli u još jednu epizodu Slobodni. Klimatske promjene, to je današnja tema. Svakodnevno slušamo, pogotovo iz mainstream medija, razne najave, razne opasnosti, a da ne kažem da i naša vlada u fokus svojih budućih planova ima na visokom mjestu, ja bih rekao čak i na prvom, dekarbonizaciju. Da li je uistinu takva opasnost od klimatskih promjena i da li je dekarbonizacija jedino rješenje? Najbolje da razgovaram sa nekim koji uistinu razumije o čemu se radi i on koji se bavi uistinu i znanošću. Stoga današnji moj gost je gospodin Roger Pielke Jr. Hello Roger, welcome to our show in Croatia.
Thank you. It's wonderful to be here with you.
It's a pleasure. Can you tell me a few words about your background?
Yeah, my background is at that messy place where science and politics intersect. I study how science is used and these days often misused. And for about 30 years, I've been actively engaged in climate research, looking at the science, the impacts, and the policy questions.
Great. I would like to talk today about science. Of course, we have to mention politics, but science is the most important thing. Can you tell me, is there a climate emergency?
So the Intergovernmental Panel on Climate Change, we'll reference that a lot, the IPCC, every few years, every 5 to 7 years, they produce an assessment report. And the assessment report summarizes what the scientific community thinks they know and don't know, importantly, about climate change. That report does not use the phrase climate emergency. Climate emergency is something that has been characterized by political advocates and politicians more than you will find in the scientific community.
Well, then we can say that we can discuss about climate, but word emergency we don't need to use.
Yeah, I mean, people will take a look at risk and they will come to different judgments as to how important it is, how pressing it is. I don't personally use the phrase climate emergency because any action on mitigation, decarbonization is a century-long project. It's not really suitable to an emergency type framing.
An IPCC assessment report 6 says that everything is connected with CO2, that CO2 is the main reason for climate changes. What do you think about this statement?
Yeah, so it's important to understand what climate change, the phrase, actually refers to in a scientific context. It refers to a change in the statistics of weather over very long time periods, 30 years, 40 years, and longer. So climate change is not an instantaneous process. It doesn't happen very quickly. But scientists have known for a long time, many, many decades, that the emission of carbon dioxide, primarily through the burning of fossil fuels, changes the energy balance of the Earth system. And when you change the energy balance of the Earth system, that changes how the climate behaves. And with that comes some risks. So it's very well understood that we are indeed affecting the climate system. There are other effects also. We change how the land is used. We change the albedo or the color of the surface of the Earth and changing heat processes. So it's a very complicated set of phenomena. But the basic reality of humans impacting the climate system is very well established.
Well, we are listening all the time that all emission of CO2 in the last 150 years is cause of burning of fossil fuels, exactly anthropogenic reasons.
Yeah, so the increase in the amount of carbon dioxide in the atmosphere can be directly traced to the combustion of fossil fuels, coal, natural gas, petroleum. And that's undeniable. There are also land use effects when we clear the land or we burn biomass for clear farm areas and so on. But the primary driver of increasing carbon dioxide is the burning of fossil fuels.
And how we can measure what is anthropogenic reason and what is natural reasons?
Yeah, I mean, the scientific community is pretty clever on these things, and they have an ability to take a look at the carbon dioxide in the atmosphere and to date where it came from, such as using the presence of the nuclear tests that were in the atmosphere in the 1950s, for example. Also, the scientific community is able to create a so-called budget. So we know how much fossil fuels are burned every year. We can add up how much carbon dioxide emissions result from that, and then we can compare that to the natural carbon cycle and create a budget and understand really the sources and the sinks of carbon dioxide.
And what these sources, exactly this climate budget saying, how much is natural reasons, how much is burning fossil fuels?
Yeah, the primary increase, the most carbon intensive fuel that we have is coal energy. Natural gas is about half as carbon intensive, and petroleum is somewhere in the middle. So really historically, coal has been the driving factor in the increasing proportion of carbon dioxide in the atmosphere that comes from human activities.
I read one paper who says that, and this paper is referenced in IPCC report, they said that carbon dioxide stays in the atmosphere between 50 and 200 years, even up to 1,000. But from the other side, I read a paper that says this cycle is changing every 5 years. That means 20% of this cycle is changing every year. Who is right in these estimations?
Yeah, the current understandings and the consensus view is that carbon dioxide stays in the atmosphere for time periods much longer than human lifespans. So if we're concerned about it as an issue and changing the energy balance of the Earth system, then it's a long time. And so the only way that you can really deal with that is you can stop burning fossil fuels, you can capture those emissions, or you can directly remove carbon dioxide from the atmosphere. Carbon dioxide is not going to go away on timescales of 5 years.
Mm-hmm. And can you tell me, now we have focused on decarbonization, and decarbonization has this goal to decrease amount of carbon dioxide. But if it stays additional 50 or 200 years, that means during our lifetime, nothing will change.
Yeah, what we can modulate, what we can affect is how much we put into the atmosphere. And because it stays in the atmosphere for a long time, when we keep putting carbon dioxide in the atmosphere by burning fossil fuels, it just accumulates and it adds to the energy imbalance of the global system. So the way that, and it's really kind of some simple math, the way that we reduce our emissions of carbon dioxide is we get off the most carbon intensive fuels. Coal should be at the top of that list. And there are a lot of other technologies such as nuclear, geothermal, solar, wind, and so on that offer the prospect of reducing the carbon intensity of our energy supply.
And the main impact of CO2 is increasing temperature, greenhouse gases effect.
Yeah, so the most certainty that scientists have that where they detect a change and they what's called in the technical term attribute it to human causes is a change in global average temperature. And global average surface temperatures have increased over the last century. And that's it's not the same in every single place around the world, but the strongest understandings are in temperature, but also in what's called ocean heat content. Most of the accumulating heat in the global system actually goes into the oceans. The oceans are a much bigger reservoir of heat than is the atmosphere. So they have these multiple different ways to measure how the energy balance of the Earth system is changing. And the strongest evidence, according to the IPCC, and I think this is right, is to be found in the oceans.
And we have also some examples, studies that shows that after we have now about 420 ppm concentration of CO2. But I read a study that says after 300, there can be it's a saturation, and there is no big impact on temperature anymore. That depends. If it comes to 500 or 600, temperature will not rise because it came on the level of saturation. What do you think about this?
So if you take a look at what the IPCC says about this, it is absolutely true that every additional bit of carbon dioxide we put into the atmosphere has a less of effect on temperature than it did in the past. That said, the IPCC projects that if we continue to emit carbon dioxide, temperatures will continue to increase. So there's not a point where we say, all right, it's done. There's no more temperature increase to come. As long as we keep emitting carbon dioxide and it keeps adding up in the atmosphere, temperatures globally will continue to increase.
And how much increased temperature from last ice age, little ice age, it's from 1850 until 1900?
Yeah, so the IPCC, you're exactly right. They use a baseline of 1850 to 1900, so the end of the 19th century. The best estimates right now, and they're conditioned on what's called current policies. So think of this as where we're heading based on the policies in place today, is that the world might see something like a 2.4 to 2.7 degree temperature increase from the end of the 19th century. From today, that's about a 1 degree, 1.2 degree temperature increase from where we're at today.
And there is an effect calling urban heating island. And this effect has some impact on the temperature. How much?
Absolutely. Anyone who's been in a city on a hot day and you're standing on a street with pavement and concrete knows that the urban environment heats up very quickly. It's much different than being in a forest or in a field. The urban heat island is another way that humans affect our local, what's called microclimates. And it is significant because if the overall temperature is warmer, and then you have these effects in large cities where the urban heat island increases temperatures, that makes temperatures even higher. So it is absolutely true that in urban areas, when temperatures are very high, it's not just or simply because of carbon dioxide emissions. It's also because of the built environment that we live in.
Mm-hmm. Okay, there is one more thing also, what everybody is discussing. It's about this graphicon named hockey stick. And this is something that somebody says it's totally wrong, but still IPCC using this as a measure. What is your opinion about this?
Yeah, so there's been debate over what's called the so-called hockey stick, which shows temperatures were relatively constant for thousands of years and then jumped up dramatically around the beginning of the last century. I don't know that debate is particularly relevant to how we think about climate policy and decarbonization today. We have a very good understanding that we do alter the energy system. So the reality of climate change doesn't really need the hockey stick today. I know there are very technical statistical debates that go on about that. But one of the things when I talk to policymakers, I explain that paleoclimate, the distant past, is very interesting scientifically, but it's probably not at the top of the list of things they should worry about as we think about energy policy going forward.
Well, let's go further concerning greenhouse gases. The most important is not CO2, it's water vapor. Can you explain us this system, how it works?
Yeah, so the atmosphere is obviously a very complicated place. And the Earth is in a careful balance between the heat going in and heat going out. And so when the heat accumulates in the atmosphere, we have a general warming. So CO2 acts to amplify the effects of water vapor in the atmosphere. And we're all familiar with water vapor. That's what causes rain and so on. So it's not a very simple set of processes. And it's one of those things where people will say, well, there's a lot more water vapor than carbon dioxide. Yes, that's true, but that does not mean that carbon dioxide is irrelevant.
And also, I was reading that clouds are very important, and 60% of clouds is above the oceans. And this part of clouds, that this is not calculated well in this IPCC assessment reports. Is it right?
Yeah, so I mean, obviously, modeling the global Earth system is an enormously challenging task, and all credit to the scientists who take on that challenge. there's a big difference between being able to accurately predict what's going to happen in the climate system going forward versus understanding that we're changing it and the future has some risks and may be fundamentally unpredictable. Clouds that you identify are one area where climate models are far from perfect. And so I try to tend to view climate models as a qualitative tool. They tell us something about how we're changing the system and the risks we may face. They are not crystal balls. They don't tell us what's going to happen with a lot of precision or accuracy, but they do tell us that we are affecting the climate system. And that, from a policy perspective, that should be enough to get us to the starting line.
And what has the biggest impact on clouds? Is it CO2 or water vapor, or there is some impact from sun cycles?
So the answer to that question is yes. Water vapor is obviously the most important factor for clouds because that's what clouds are comprised of. Carbon dioxide changes heat and heating patterns. That also changes clouds. But also any place where there's, for example, agriculture and irrigation, and we change the land surface. Actually, my father, who's retired, has been a pioneer in work on land surface processes and how they affect the climate system. That affects where it rains, how it rains. Urban centers also affect clouds and how they develop. Anyone who's seen very large forest fires, perhaps in the news or online, sees that forest fires create clouds and they create their own weather. So there's a lot of processes that affect clouds, and that's one of the things that makes it very difficult to model them in the sophisticated climate models.
What about sun, total sun irradiations? Is there any effects from sun to creating clouds?
Yeah, I mean, obviously, if you go outside at night and you go outside the next day, you can feel the sun yourself, and the sun is central to the Earth system and global climate. There's a lot of discussion and debate over the relative role of solar changes over time. The consensus views right now of the IPCC are that the solar factors are a smaller factor, much smaller factor than the forcing that we're causing through the emission of carbon dioxide and through the burning of fossil fuels.
And what about volcanoes? Volcanoes also creating some kind of clouds, especially if they're coming under the water. They are creating clouds. At the same time, also they're creating layers to protect from the sun.
Yeah, absolutely. It's been well understood that volcanoes, the largest volcano eruptions, have dramatic effects on climate. You can go back to the beginning of the 1800s, 1815, Tambora led to what was called the year without a summer, because when the volcano erupted, it put all sorts of soot and particulates into the upper atmosphere that blocked out the sun and made things cold. 1991, Mount Pinatubo erupted and had a cooling effect on the global climate. More recently, the Hunga Tonga eruption, which was a very unique volcanic eruption, resulted in shooting massive amounts of water, which became water vapor, into the stratosphere. And the research is only now beginning to come out. There are debates that are occurring as to what the longer-term effects of Hunga Tonga are. And this gets to why climate is fundamentally unpredictable, because we can't predict when the big volcanoes will erupt and what their net result will be on the climate system. We know they will occur. We don't know when they'll occur or how big they are. But again, volcanoes are part of the Earth system that dramatically affects climate.
What about melting the ice? I heard that ice is melting also because underground volcanoes, that is the first reason. And then after that, maybe if it is melting of ice because of global warming.
Yeah, again, the scientific community creates a budget to understand sea level in particular. And sea levels have been increased. They've been increasing since the last ice age, and they may be accelerating now. But the scientific community, now that they have satellites, is able to very carefully estimate sea level rise. And one of the things they try to do is estimate what are the sources of the increase in sea level. One of the sources is that as the planet warms, the ocean expands. It gets a little bigger, so that causes sea level rise. But another, as you indicate, is the melting of ice sheets and glaciers. that lead to runoff that flows into the ocean. It's not just temperatures. When we burn dirty fuels, coal in particular, or there's soot, say from forest fires or agricultural clearing, that can precipitate out on top of snow or glaciers, make it darker, and that absorbs more heat, which leads to more melting. So it is very well understood that there has been a general melting of, say, the Greenland ice sheet, glaciers in Europe and elsewhere that have contributed to sea level rise.
I also read that measuring of sea level rise from side of satellites has to be very careful measured, because we cannot totally rely on this measure what we have presently, and especially this one what was presented in IPCC.
Yeah, sea level rise is tricky because the sea isn't the only thing that's moving out there. The land goes up and down in different places. And particularly in urban areas, when we pump out groundwater from underneath cities to use for human consumption, that can cause a general sinking, such as in Bangkok, for example. So that makes it very difficult. Over the last 30 or 40 years, there have been very sophisticated satellite instruments, satellite altimetry that has been launched into space that allows for a much more precise calculation of sea level rise around the world. But again, it's a short record. It's only 30 or 40 years, and it doesn't tell us anything about the longer term century or more time series.
Yes. Well, I read that there will be new satellite who will bring up with a new, especially for the climate, with the new measures from 2026.
Yeah, I mean, this is a positive aspect of science, but also frustrating, is that we are always getting better tools to measure the climate system. But to understand climate and climate change, you need very long-term records. You cannot understand the climate system on a yearly or even a decadal time period. So yes, it is wonderful to have these new records, but it's not going to revolutionize the science overnight. It is going to take some time to collect the data and analyze it and understand what it means.
Mm-hmm. Okay, now let's go to other impacts on the climate. We have a multi-decade Atlantic variation and also decade Pacific variation. Can you explain us how big impact of these two variations have?
Yeah, so the IPCC identifies a number of what it calls modes of variability. The climate system oscillates, it varies, it has its own internal variability over all time scales. Everyone is familiar with this, for example, in the most obvious mode of variability, and that's the seasons, right? We go from winter to spring to summer, and that's because of the position of the Earth with respect to the sun. But there are other modes, and these have an effect on local and regional climates. Many people will be familiar with El Nino. It's in the media a lot, which refers to a warming or a cooling of the Central Pacific off the coast west of South America. That has what's called teleconnections and affects climate from Southern Africa to the United States to Asia to Europe and so on. This is one of the factors that makes it very difficult to identify the consequences of human-caused climate change on the climate system, because the consequences of human-caused climate change occur in the context of this pre-existing internal variability of the climate system. And so the IPCC identifies about 8 to 10 modes of variability which operate on various timescales that are more or less understood. But we do recognize, as you said, in the Atlantic and the Pacific, there are these very profound modes of variability that affect climate systems.
And there is this cycle of warming and heating from 60 to 80 years round, and we are now, as I understand, in the middle of one. In the next 5 years, this will be changed. What do you can say about this?
Yeah, I mean, the one thing to understand is that when people talk about cycles, we don't have really long-term records that would allow us on century timescales, as you know, 60, 80, 100 years and longer. Our records don't go far enough back. So if you have one cycle or 1.5 cycles, we should exercise a lot of caution in trying to interpret it if that is an actual mode of climate variability. It's much easier to see the effects of El Nino because El Nino occurs on 3 to 5 year timescales, and we have good records back to the 1800s. So we know that is a mode of variability.
Let's go to these cyclones and tornadoes. They said, I read a paper also that said that there is no bigger frequencies and there is no much stronger cyclones and hurricanes in the last years. The only reason why we have more damage because people who are living there has more wealth and there is more people living in the area when this cyclone is happening, and that is the real reason. We don't have to worry about bigger number of and stronger cyclones or hurricanes.
Yeah, I mean, this is one area where the science that you find in the IPCC is dramatically different than what normal people will read in the media. If you look at the media these days, every storm, every flood, every heat wave, every event is attributed to human-caused climate change, as if we didn't have those events historically. So, another frustration I have is not many people actually read the IPCC reports. If you go into those reports, you will find that tropical cyclones, which includes hurricanes in the Atlantic, their behavior has not been attributed to human-caused climate change. There are some interesting hypotheses out there. In the United States, for example, since 1900, at least, there has not been an increase in the number or intensity of hurricanes that strike the United States. You're absolutely correct. Damage has gone up dramatically. And the reason, we can explain this, and this is some of my own research, is because there's more people with more property and more wealth in harm's way. It's very easy to have a headline that shows a lot of damage or in some cases tragically loss of life and say this was caused by climate change. But by and large, the IPCC and scientific community do not support such claims for tropical cyclones, for flooding, for tornadoes, for winter storms. There are a few places where there is some confidence that human-caused climate change is associated with increasing extreme events, and that's heat waves in particular, and in some places what's called extreme precipitation. That's higher precipitation than is typical. That's not the same thing as flooding. So extreme events are very photogenic. They're very easy to use in political advocacy, but the science isn't really quite there to support a lot of the claims that are made out in the public.
Is there more wildfires than before?
Yeah, it's a good. So overall, on the Earth system, over a period of, let's say, 30 years, more or less, there has been an overall decrease in the burning of lands on the planet. That is largely due to a reduction in burning of lands for agricultural purposes to clear the land. Forest fires have increased in many places around the world, in the western United States, along the Mediterranean, for example. Teasing out why that has happened, again, is a very complicated exercise because we manage forests, we live in forests. Most of the ignitions of forest fires are from humans, human activity. The IPCC does not render a judgment on wildfires. It assesses what it calls fire weather. These are conditions that are hot and dry. And it has seen indications that fire weather has increased, but it does not have high confidence in those findings yet.
Is there an increasing of deserts in the world?
Yeah, the issue of desertification when I first started in the 1990s was a big deal, and people were concerned that deserts would be expanding. There's less concern about that today than there was in the past. We certainly manage the Earth's surface in different places more or sometimes less well. But the expansion of deserts overall has become less of a concern than it was in the 1990s.
Now we have to go more focused on agriculture. That's a very important thing. How agriculture and on which way has an impact on climate?
Yeah, so agriculture has a number of different impacts on the climate system. There are direct emissions of nitrous oxide, of carbon dioxide from agricultural practices. When we plant crops over large areas, so think of the Midwestern United States, which is full of corn. Corn gives off water vapor. It changes the albedo, the color of the Earth system. So agriculture has a lot of different effects on the climate system. Remarkably, humans are inventive and have done a wonderful job of producing more and more food around the world without taking up more and more land. So agriculture has intensified, and the current projections are that future climate change, depending on its magnitude and how it plays out, will have effects on agriculture. But at the same time, our ingenuity, our technological advancement, such as with genetically modified crops and so on, agricultural biotechnology, will stay out ahead of climate change, and there will be enough food going forward. And the positive side is that perhaps we continue to produce as much food as the world needs using less and less land. The last thing I'll say about that is population growth is slowing down and is expected to peak sometime in the middle of the current century. And if that actually occurs, then the demand for food worldwide will eventually reverse and go the other direction.
What about meat? What about cows? Are they have any impact?
Cows have a direct impact. They emit methane through their burps, which affects the climate system. Beef in particular is a very carbon intensive form of food. There are a lot of people studying how do we mitigate by what we feed cows, or how do we capture their methane. There have been people who suggest, well, let's change our diets and so on. Meat is a very culturally important issue in different places around the world, whether it's beef or pork or lamb. And so my view is it's a lot harder to change people's culture and practices than it is to come up with technological solutions to try to reduce the emissions or consequences of emissions. So I think we should expect, as large parts of the world become more wealthy, as they have the ability to eat food like rich people do around the world, that we will continue to see an expansion of the consumption of meat. And so that's something we're going to have to deal with.
What kind of technological solutions we have now for these problems?
Yeah, so with cows in particular, I have seen studies where they change the grain and the feed that cows have so they emit less methane. There are also places where you put your cattle herd inside of a structure and you capture the methane. Methane, it's important to understand, is natural gas, and methane is a fuel. And so if that can be captured, it can be repurposed, and then we have a less carbon intensive fuel source, less methane intensive fuel source. So there's a lot of effort going on in a lot of different sectors to figure out, well, how does mitigation work in a way that's cost effective? If you capture methane from cows and use it as a fuel, maybe you have a net economic benefit. So I expect those sort of things to continue.
Mm-hmm. Okay, now we come back again to temperatures. Well, there is increasement of temperature in the last 150 years. How this increasement has an impact of human health and human environment?
Yeah, one of the worst places to look for the effects of changing temperatures is on human well-being. We are a fortunate generation in the history of this planet. Over the last 100 years, we've seen things like the invention of antibiotics. Public health and medicine has advanced. Human lifespans have doubled over the last century. Far fewer children die from the diseases, still too many, but through vaccination, public health, the availability of food, humanity has been on a roll. And so it is very difficult to look at the fate of humans right now and say, well, things are going bad or things are going downhill. That's simply not the case. When we look at the effects of climate change, we have to look at their physical effects on the climate system. And that does pose risks that we need to be aware of. But, and this is, if you look at disasters, for example, in the 1920s worldwide, millions and millions of people died from extreme events, whether that was drought or floods or tropical cyclones. Over the last decade, it's been several orders of magnitude less. Still too many, but tens of thousands, not millions. So we do pretty good adapting to climate going forward. And if it was only concern about human well-being, probably climate change would be a much less significant issue than it is. But we are affecting the global planetary system, ecosystems, And that's what poses the largest risk.
Well, I saw lots of headlines that said so many people dies because of climate warming. But is there more people that die from climate warming than from cooling?
Yeah, so more people, and the data is very strong on this. Worldwide, more people die from extreme cold temperatures than extreme warm temperatures. Anyone who's been outside in winter fully can understand that, especially in very cold places. No one on the planet should die from extreme heat or extreme cold. We know absolutely the steps to better adapt to those extremes. And so this is something that we often don't talk about. We think about climate sometimes as a causal actor, and it makes things happen. And the reality is that we're the causal actors, human beings, and we have decisions in how we live, where we live, how we adapt to climate variability, to climate extremes. There are many places around the world where people are exposed, they're vulnerable to climate impacts. People in Europe, in North America, are much less exposed or vulnerable to climate impacts than elsewhere. And part of that has to do with wealth. And as the world continues to get richer, I think we're going to see improved adaptation in many places that are not optimized today.
I have so many questions for you, but we have to deal with other things what are very important here. Well, there's assessments, 4 different assessments for the future. What is your opinion? What is the most likely one to happen? And explain which kind of assessment is for until 2100 year.
Yeah. So historically, the IPCC has used scenarios to project the future. Scenarios are plausible storylines about how the future might play out. They're not predictions. They're not forecasts. We can't predict the future very well. Right now, the scenarios that the IPCC uses are out of date. They're 20, 25 years old, and they're in the process of updating them. But if you take a look at the most recent research on where we are headed, it suggests that global temperatures will continue to increase, perhaps 2.5 degrees Celsius by 2100. That's not the 2 degrees or 1.5 degrees of the Paris Agreement, but also it's not the apocalypse. It's not the end of the world. So climate change is going to be something that we continue to have to deal with. On the other side, on the human side, how we choose to develop economically, to expand access to energy in places that don't enjoy the energy services that we enjoy every day, those are choices. Those are policy choices. And there are issues like wars, pandemics, bad politics, people who fight with each other, that will get in the way. And so, the most important thing is to realize we have free will as a species, and we can decide to make things better or worse. I'm very much of the view that climate is an annoyance. It's a problem, but it's not the apocalypse. It's not the end of the world, but we can't ignore it either. So it's one of those features of living on planet Earth that we have to deal with and accommodate, recognizing that the future is fundamentally uncertain.
Yeah, this is very important what you said, because now we're coming to the economy. I read a report from McKinsey, and it says inside that we have to invest 9% of GDP globally until 2030, and additional 6% of GDP until 2050 for reaching the goals of net zero. What do you think about this?
So I wrote a book a while ago, and in that book, I coined a term called the iron law of climate change. And in that, I said that most people around the world appreciate the environment, and they're willing to pay some amount of money to achieve environmental outcomes, but not a lot. People they have to feed their families, they have to pay for their heating bills, and so on. So the willingness of society, and I believe this is universal around the world, the willingness of individuals to pay for climate policies has a hard ceiling on it. So the only way that we achieve decarbonization goals, whether that's net zero or something else, is to come up with policies that make people better off while that happens. Make people wealthier, make them more secure, give them energy access, low energy prices. So these consulting studies, such as from McKinsey and elsewhere, that suggest we have to pay X% of our GDP going forward, Politically, it's just not going to happen. People will not allow that to happen. And it's not just in democracies where they can vote out people, but in other countries as well, where people are very sensitive to the price of fuel and electricity. So this puts the challenge back on policy experts. How can we come up with policies that make people better off at the same time we're reducing the amount of carbon dioxide emitted into the atmosphere? We're a super smart and inventive species. I have no doubt that we can do that if we put our mind to it.
Yeah, I was reading also that lots of people, experts, says that we will be less wealthy if we invest so much money in decarbonization.
Yeah, and that's exactly why I don't think things will go that way. Because no politician on planet Earth that I'm aware of has ever run for office on a campaign of making people less wealthy. That's not a winning campaign message in Croatia or the United States or anywhere else. So the challenge is, how do we make people actually more wealthy, have more material abundance, while at the same time decarbonizing? Too often, the climate debate becomes one where advocates for action try to use scare tactics. And it could be scare tactics about the climate system itself, could be scare tactics about the environment. People opposed to climate policy sometimes use the economy as a scare tactic. I wish we would get past a lot of that and get more into, we understand the boundary conditions of what policy design has to be. So let's work to try to fit that, because everyone's better off if we go in that direction.
Well, I saw that that economy of renewable energy is now already reached economy of fossil fuels. It's about 6% of stock exchange, and it's estimation that will come up to 10%. What do you think about this renewable energy? Is this really renewable, or there is also problems in this kind of production?
Yeah, I generally don't use the term renewable energy. I use solar, I use wind. They're very different technologies. For instance, I am very positive on solar energy expanding, much less so on wind energy. But if you do the math, if you look at the global energy system, and it's important for people to understand, currently the global energy system is still about 80 to 85% fossil fuels. So there has been an expansion of wind and solar, but there's a long way to go if we want to get anywhere close to net zero. I personally cannot do the math without a large presence of nuclear power. Nuclear power, I very much believe, if it were invented in 2024, people would be holding it up as a miracle solution to climate change. It has a lot of history, a lot of baggage associated with the Cold War, with nuclear weapons, with Fukushima, with Chernobyl. And every energy technology has its positives and its negatives. But if the goal is to dramatically reduce carbon dioxide emissions, nuclear energy is a big tool to do that. It's perfectly legitimate for people to be afraid of nuclear power. And it's perfectly legitimate for people to be afraid of climate change. But if you're afraid of both of them at the same time, then you have a math problem.
Yeah. Well, there is also one more fear from side of people. It's that we have to act globally, because if we don't act in China and Europe at the same time in the United States, there will be no result. But people are afraid that we'll come up to the global world government who will undemocratically lead all these processes and use the forces to implement their policies without democracy, without asking people. What is your opinion about these fears?
Yeah, I mean, I think those are legitimate fears, because the way that we solve this issue is not through top-down mandates or policies of imposing solutions on people. And this is why technology is so powerful. I mean, look around the world. There are billions of smartphones around the world. People have smartphones not because they've been mandated from the top down, but because they're useful. They make their lives easier, more efficient, better. It's the same with energy technologies. If we accessible, reliable, cost-effective energy systems, people are going to take them. If all you have is a big pile of coal on your in your country, that's what you're going to burn. And so there are many places around the world that have fundamental energy security issues. We see this raised with the Russia and Ukraine. We see this with Europe continuing to import Russian gas. If the choice is between the lights going out and sourcing fossil fuels, even from a dangerous regime, we're going to source those fossil fuels from that dangerous regime. So this is where technology has to be front and center in any approach to decarbonization. I would argue it has to be front and center in future economic growth, because there are billions of people today around the world who lack energy access, who want it. Energy consumption around the world is just going to go up in future decades. And we collectively as a species are going to have to figure out where is that energy going to come from. Because if we don't, it's going to come from the most available sources, which in many cases is coal, which is very dirty, not just for carbon dioxide, but for air pollution and also for the land surface and how we dig it out of the earth.
Yeah, and there is one logical question, I think. We want at the same time totally digitalization, and that take lots of energy. And now how can you do it? Decarbonization at the same time with the total digitalization without enough energy sources.
Yeah, so this is an issue, particularly in the United States right now, that the rise of data centers and artificial intelligence has resulted in projections of rapidly increasing energy demand after about a decade or more of very flat demand in the United States. If demand is flat or falling, such as we've seen in Europe, it's much easier to decarbonize than if demand is rapidly increasing. There are places like China, India, that are seeing steady increases in energy demand. That focuses the attention of trying to decarbonize in a way that falling energy or stagnant energy just does not.
And we didn't pass all these things. I didn't mention Iris effect. I didn't mention other things that they are mentioning in this climate changes science. But the most important thing, I think, is what is the message? Because we are listening every day from the mainstream media, cataclysmic estimations and fear-mongering all around, people that very soon will stay without any sources. Very soon there will come all floods and we lose everything. What is your message for people who are listening this from the scientific stance, not from the politician? What we can expect, and should be afraid of disasters because of climate changes?
Yeah, I mean, the climate issue is really a unique one in that understanding what the science really says is very difficult because of the political overlay on the climate issue. It would be great if we could just cleanly separate science from politics, but that's not going to happen. We need to see better leadership from the scientific community to offer correctives to very extreme media stories to politicians. The IPCC, in my view, is very good. It has very good information, and it's very much at odds with what normal people hear in the media and from politicians. So the scientific community needs to stand up for science in policy. Climate change is real. It's serious. It poses risks. But I sleep well at night because I know that humanity has overcome a lot of challenges, whether it's disease or wars. And climate change is a challenge, to be sure, but it's not the apocalypse, and people shouldn't think that it's the apocalypse. We should put our heads down and get to work and make sure that we are more resilient, robust, less vulnerable to future climate, whatever it throws at us.
One more question for end. What about geoengineering? Human impact on the climate, on the weather?
Yeah, geoengineering refers to efforts to intentionally try to modulate or affect the climate system. I'm not a fan. We certainly don't understand the climate system well enough to be tinkering around and trying to mess with it in a way that leads to preferred outcomes. I'm very much a light touch on the climate system. It's kind of for people of a certain generation, Dr. Strangelove or a Frankenstein sort of a story. So I am not a fan of geoengineering. I do not think we should be tinkering with the climate system. Let's just reduce our impact because that's challenging enough, but we do know how to do that.
Thank you, Roger. You continue with your work, and whoever wants to read can go to your Substack And really this is source of very good information and understanding of climate.
Thank you. Appreciate the opportunity.
Evo, dragi narode, meni se čini da je ovaj dobar pristup razuma, znanosti oko jedne vrlo važne teme. Dakle, slušajući i gledajući naslove mainstream medija, jedino se možemo bojati da nema naše budućnosti. Međutim, kada uđete dublje, pročitate reporte, znanstvene reporte, i kada pročitate i poslušate ljude kao što je gospodin Pielke Jr. ili gospođa Judith Curry, koju sam također imao prilike ugostiti, onda vidite da ta znanost govori nešto opreznije i nešto stručnije o tim problemima, pa tako i tom problemu, odnosno rješenju tog problema, prilazi malo razumnije. Sva taj strah koji dolazi od medija ili poruke koje šalju političari u stvari ima u pozadini neki drugi interes. Ili interes da su dobili novac za to, da šire propagandu, ili interes da koristeći klimu i klimatske promjene provedu neke svoje politike. Recimo, ja vidim veliku mogućnost, odnosno veliki potencijal da se smanje ljudska prava i slobode pod isprikom spašavanja planeta, koje, kao što vidimo, treba paziti. Ali da ga treba baš spasiti, nisam baš potpuno siguran, jer ne treba spašavati nešto što nije tako ugroženo. Moj cilj je razgovarati o toj temi sa stručne strane, pozivati ljude iz cijelog svijeta, jer mislim da je Hrvatska premala da bi dovoljno znanosti imala za ovu temu, i prestati slušati naslove i one koji žele takvim naslovima pridobiti takozvane clickbaitove, dakle gledanost. Jer strah je najbolji motiv da dobijete pažnju. Racionalni razgovor, mirni, sa argumentima, nije zanimljiv ljudima. Uvijek je puno zanimljivije kad predviđate neku katastrofu. To smo vidjeli i u pandemiji, to sad vidimo sa klimatskim promjenama. Stoga dovodim vam goste koji, kao što vidite, imaju što reći o toj temi, pa ne bi bilo loše da i vi, nakon što kažu to što imaju, odete na njihove Substacke ili internet stranice i pročitate redovite objave, kao što to činim ja, i onda ćete bolje razumjeti u kakvoj se stvarnoj situaciji nalazimo i da li su postojeće politike uistinu za svrhu spašavanja planeta i promjene klimatskih uvjeta, ili se zloupotrebljavaju kako bi se provele pojedine politike koje u normalnim uvjetima ne mogu ljudima nametnuti, među kojima ja vidim jednu od najzanimljivijih, to je ova koja se provodi u gradu Zagrebu, 15-minutni gradovi, u kome nas po svaku cijenu žele staviti u okvire ograničenog kretanja kako bi spasili planet, a evo, možda taj planet, kao što vidite, nije potrebno na takav način spašavati. A ta politika doslovno može poslužiti da nas stave u digitalne zatvore, pošto će kroz digitalizaciju moći pratiti svaki naš korak, takozvani karbonski otisak. A evo, danas smo pričali i o poljoprivredi, i o hrani, i o konzumiranju mesa, i o konzumiranju onoga što nam nude kao alternativu za meso. Dakle, poslušajte, razmislite, pročitajte, pozabavite se temom. Ta tema je jako važna jer je na vrhu politika koje se trenutno vode u Europskoj uniji, pa tako i u Hrvatskoj, i silni novci koji smo među ostalima se zadužili i moramo ih vraćati do 2058. godine u iznosu po današnjim cijenama 806 milijardi eura. Čak 37% tog novca moramo uložiti u takozvane klimatske promjene, odnosno dekarbonizaciju. Pa ako ćemo tolike novce uložiti kako bi nam energija bila skuplja, da pri tome nismo sigurni kakav ćemo rezultat postići, onda moramo se postaviti pitanje tko je odlučio da provodi takve politike i zašto. Hvala vam lijepo na pažnji i uskoro se vidimo u sljedećoj epizodi Slobodni.
Nitko vas neće natjerati da se poklonite zvijeri, učinit ćete to svoje voljno, odbacujući vjeru. Bićete laka meta za zvijeri, jer se niste podredili vjeri. Ako se ne podredite vjeri, podredit ćete se zvijeri. Toliko ćete se suobličiti sa ovim svijetom, da nećete ni prepoznati da ste u zabludi. Biće to najveća demonska prevara ikada i pravedno zaslužena osuda nad nepokajanim grešnicima.